Hello everyone. In this video, we'll understand how do we model using recurrence relation Tower of Hanoi problem. First of all, what is Tower of Hanoi problem? The Tower of Hanoi is a mathematical puzzle which consists of three towers like this: source A, auxiliary B, destination C, and more than one disk in source A like this. These disks are of different sizes, which we may clearly notice here, and stacked upon in ascending order. That is, the smaller one sits over the larger one. This is smaller, larger, and then next large, and largest. The number of disks may change. This may change, but the number of tower count remains the same only. It is invented by French mathematician Edward Lucas in 1883. The first tower is considered as source tower A, the second tower is auxiliary B, and third is the destination tower C. Here the mission or the objective is what? We need to move all these disks to this destination C without changing the order, and there are some rules involved in it. Only one disk can be moved among the towers at any given point of time. Means even if I move the topmost disk, only one disk only I can move, and that is considered as one step. Only the top disk can be removed. No large disk can sit over a small disk. Means suppose, for example, if I'm shifting this here, I cannot put this green on the top of this blue. Means always the smaller disk should be on the top of the larger disk, or larger disk cannot come over the smaller disk. These are the rules. Now, considering these rules and this objective, let us see if the number of disk is only one, then how many steps it involves. If it is only one, means I can simply, for example, if this is here, actually initially it is here, and if I have to move this to destination C, it will just take only one move only. I can simply shift this to here. That means if the number of disk is one, then the number of steps to move that particular disk is only one. Means number of disk one means number of step is also one only. Now let us see if there are two disks, what will happen. There are two disks. One is yellow disk, which is the larger one, and this is smaller one compared to yellow, blue disk, right? Now, what is the step first? I will first shift this blue disk to auxiliary disk. Now, this yellow disk can be moved to the destination, which I will be doing it in step 2. I can move that yellow disk to destination C. Now, in the step 3, I can move this blue disk and bring it to destination C on the top of yellow disk. That will be in the step 3. That means if the number of disks are 2, the number of steps to be taken is 3. Now let us see what will happen if the number of disks are 3. Let us consider this yellow, blue, and red. Now what are the steps? First step is I will shift this red disk to destination C like this. Then I will shift this blue, that is one step, step 1, and then I will shift this blue disk to auxiliary tower like this. That is step 2. Now, what I will do, I will bring this red disk on the top of this blue disk in step 3. Now, this is blank. I can shift this yellow disk to destination C, which will be our step 4. Yes. And then subsequently, I can take this red disk to source A again, because I need to have this blue disk on the top of the yellow disk. For that reason, I'm shifting this red disk to source A in step 5. Now, I can shift this blue disk to destination C, which will come on top of the yellow disk. Now, finally, in step 7, I will bring this red disk to destination C. That means the number of steps involved, if there are 3 disks, then it is going to involve 7 steps. Now that we have already seen, if it is 1 disk, it is going to take 1 step only. If it is 2 disks, it is going to take 3 steps. If it is 3 disks, it is going to take 7 steps. Let us put this one in. Let us see the table now. In the table, if the number of disks is, we are going to call number of disks as n and number of steps as t of n. And we had already seen if the number of disks is 1, then t of 1 is 1 step only. If number of disks is 2, then t of 2, it is 3 only. Number of disks, it is 3, then number of steps is 7. Now, I am going to express this t of 2 in terms of t of 1. I know 3 is nothing but 1 plus 2. So I can say t of 1 plus 2. And I'm writing again this 2 as 2 to the power of 1. Why I'm writing it as 2 to the power of 1? Because in the next step, we will understand if the number of disks are 3, then t of 3, if I have to express this t of 3, which is 7, in terms of t of 2, then it becomes 7 is actually 3 plus 4. So it is 3 of 2 plus 4. And that 4 can be expressed as 2 square. That is why we are writing this 2 as 2 power 1. Even if we look into this t of 1, there is no previous step, which is actually 0. So if I have to express this 1, it is nothing but t of 0, which is nothing but 0, plus 2 to the power of 0. 2 to the power of 0 is nothing but 1. So you get 0 plus 1, you get this 1 only. And so on. If I do that, I get for n minus 1 disks, you will have t of n minus 1, which I can write it as t of n minus 2 plus 2 to the power of n minus 2. Why 2 to the power of n minus 2? We may note if it is t of 2 here, then it is 2 square. If it is 1 here it is 2 power 1. Likewise, if t of n minus 2 is there, means this will be 2 of 2 power n minus 2. Similarly, if it is n disks, then t of n will be t of n minus 1, that is the previous one, plus 2 power n minus 1. Now, we are rewriting this t of n as t of n minus 1 plus 2 power n minus 2. Now I'm going to substitute this t of n minus 1, which is nothing but t of n minus 2 plus 2 power n minus 2 plus 2 power n minus 1. This term I'm writing it. And so on. If we keep on doing that recursively, then what will happen? We will get this t of 1 plus this 2 power 1 plus 2 power 2 and so on up to 2 power n minus 1. That will be your t of n. And t of 1, we know it is 1, which is nothing but 1. So it is nothing but 1 plus 2 power 1 plus 2 power 2 and so on up to 2 power n minus 1. This is a GP, a geometric mean. I'm sorry, geometric progression. This is a geometric progression. And we know in a geometric progression, if we have, let us say, sum of first n terms, if it is a plus ar plus ar square and so on, we know nth term for a geometric progression is ar to the power of n minus 1. Then this, the formula for finding out the sum of first n terms is a times r to the power of n minus 1 divided by r minus 1. So here you may notice in this expression, whatever we got here, the first term is actually 1. That means a is 1. And we also may notice that the common ratio is actually 2. So r is 2. That is why we write a is 1. So anything multiplied by 1 will be that something only. So I'm simply writing 2 power n minus 1 divided by 2 minus 1. Since the denominator is 2 minus 1, which is 1 only. So simply it will be expressed as 2 power n minus 1. So that will be the number of steps involved if we have n disks in the source tower. And if it will take 2 power n minus 1 number of steps to complete the process. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.